Yeah, then welcome to the second talk today, Demystifying Dependency Injection by Jens, my colleague. Um, yeah, I bet that Jens will tell us very nice things about dependency injection that we probably all use already. And we will now have a deeper look.
Oh yeah. And we also offer trainings, stuff like this. And what we currently do a lot is actually doing Java migrations from Oracle to Azure. Because actually Oracle got really expensive and yeah, people want to save a lot of money now just by converting to Azure. Yeah, due to being in different projects, I tend to see a lot and learn new stuff all the time. That's actually what I use to share stuff like in blog posts or talks like this. So let's have a look at what we're going today. First, I'll show you a little about what dependency injection actually is and why we even want to use it. There are quite a few terms like tied to dependency injection, which you'll actually be confronted with once you start getting a little into it. Yeah, I'll just explain that so you know. Then we'll actually have a look at how to inject dependencies, because there's a lot of ways to do it. Lots of names, smaller variations, and yeah. But injecting is not everything. Also, like the wiring of the dependencies has to be done, and there's also multiple ways to do it. And yeah, that's also what I'm going to show you. Yeah, and in the end, maybe a few frameworks, some recommendations. But let's start. So let's explain the basic concept first. What is a dependency? So here we have class A, which uses methods of class B. So B is actually a dependency of A. And in this case, we have a little problem because A also creates an instance of B. Yeah, but let's look at the code, why it might be a problem. We have some Java code here, and it actually looks a little like Spring, so the naming is kind of similar. And the user service actually creates a user repository. And the user repository might be, I don't know, access to a database or something like this. And this might actually turn out problematic because it violates the single responsibility principle, which means the user service is not only responsible. So the user service is not only using it as a dependency, but because it creates it, it's also responsible for its lifecycle. So if it's a database connection or something like this, it has to close it at some point. And yeah, it has to take care of it actually. And the classes are also tightly coupled. So I'm not actually able to test the getActiveUsers method independent of the user repository. So even though the contract is kind of clear, so the find all probably returns the list of users or something like this, I always have to call it first. And yeah, that might be a problem when I actually change something in the user repository. It might make the test of the user service fail. And that's also something we don't want to have. So the solution, you would have thought, is actually dependency injection. And what we do here is we inject in the user repository from the outside into the user service. And what we now have is the lifecycle of the user repository is now outside of the user service. Where it actually is and who takes care of it is something we talk about later. What you can do here now is, instead of using the actual dependency, we can just put a mock of it in there. So maybe use Mockito or something, put a mock in there, and now we got this dependency of the actual implementation of the user repository not anymore in there. Oh yeah, sorry, forgot that one. And it actually enables us to test this thing independently. So let's get back to the diagram we saw before. And if we apply dependency injection, it now looks like this. So class A still uses methods of class B, but the creation and injection is done by another component, or we'll talk about it later. We call it X for now. Well, let's get the naming straight. X is the injector, A is the client, and B is the dependency. So let's have a look at dependency injection. We already saw it. It implements separation of concerns, which means that the creation and the usage of the dependency are actually separated in this case. And what it basically does, it's kind of simple. It's just inserting dependencies from the outside. And we want to do it actually to test units in isolation. Be aware, a unit doesn't always have to be a single class, depends on how you test. So like you can have a testing strategy where multiple classes can also be unit. I think Sebastian here has a great talk about that one. Yeah, just a side note. And yeah, as I said before, there's multiple ways to inject. We'll have a look at it in a second. And the dependency injection itself can also be done differently. So like there's different paradigms about it: manual, compile time, or runtime. So first, when you start reading, when you get to start to read a little into dependency injection, you're quickly confronted with the dependency inversion principle. And the definitions of both are a little vague sometimes. So dependency inversion principle is often used in combination with dependency injection. But actually, dependency injection is just the injection of the dependency, nothing more. And with the dependency inversion principle, the client actually doesn't know which concrete implementation of the dependency is used. So you could also use a different implementation and put it in there. And it's actually great when you want to write a mock and pass it in there. So like you can write mocks manually. You don't have to use Mockito. Or actually fake. A fake, instead of mocks, imitates a little the behavior, and mock just returns static values. And what I do sometimes when I have, for example, use a key value store or something like Redis, I replace Redis with a fake, which just uses a hash map. And it's kind of nice because it's reusable, but be aware, depending on how your logic is, it might get complicated quickly. And another thing is, if your fake is not correct, your tests might be green, even though they're not correct. So be aware of that. Always falsify tests when you use mocks, when you use fakes. And yeah, this thing is actually a little. So why these two are actually intertwined or used together is because the old dependency injection frameworks actually required that you had to use the dependency inversion principle. Most modern ones don't need it anymore. So that's why they got a little mixed up. But when you use mocking frameworks like Mockito or something, you don't really have to use it. And for example, I always try to keep simple. So I just use Mockito and not use the dependency inversion principle if I don't want to write the mocks or fakes myself. So what you often always hear is like dependency injection is inversion of control. And it's kind of true, but actually dependency inversion is just the main principle behind it. And inversion of control is where, yeah, like in contrast to procedural programming, you don't have a single entry point, but instead you have like a framework which defines the control flow. And Spring is actually a great example for it. You have things like the request filter or the REST controller, which actually implement it. So for a request filter, all you have to do is annotate your class with add component and implement the request filter interface. And as soon as it's done and you start your application, every time a request comes in, your request filter will be called by the framework. You don't call it yourself. And the same essentially for something like the REST controller. You annotate it with the REST controller, have some methods in there, say which path they are, and Spring will call them as soon as the path is called with the matching HTTP method. Yeah. So dependency injection, I'd say actually just partially uses the main idea behind the principle. So what we only have inverted is the control of the lifecycle of the dependency, but not the control flow itself. So dependency injection is not inversion of control, but maybe like half of it, and yeah, because the part of the control flow is actually missing. Yeah, and that's when you start reading into it, you actually see like lots of blog posts or something tend to get it wrong. Yeah. And so I already said there are many ways to actually inject, and yeah, that's lots of different names, and they're often similar maybe with some smaller differences in there. And usually if you have a look at your frameworks or something, not all of these are supported. But let's put some order into that. So you can roughly structure them by actually where you do the injection. Sorry. Actually, there's just 3 ways: constructor, method, and field or property. And you can actually split it up a little further. So there's some special cases to method injection, which is setter injection, which is mainly like your method is called set x or whatever. And there's also interface injection, which means the method for the injection is defined by an interface, which you actually implement. And what you could actually do as well, just pass the dependency as a parameter in the method where you already use it. That's parameter injection then. But we can also look at them in detail. So in the first example, we have already seen constructor injection. We insert a dependency through the constructor and save it in field to actually use it later. To set it up, so like in the bottom box over there, we actually have to create the dependency first, and then inject it into the client through the constructor. And the nice thing is actually simple to use and easy to understand. And that's why actually most frameworks actually have it as a recommended way to use dependency injection. And it's also nice because all the dependencies you put in there are mandatory. So when you create the client, the dependency has to be injected. So you can be sure it's always initialized. One disadvantage actually is that it can get kind of messy. So like when you have lots and lots of things that get into a constructor, it's called overinjection. And usually if you face this, it's a sign that your class actually does too much and you might want to do a refactoring. And the easiest thing is, yeah, just extract some parts of it into another class, and usually it gets a little more tidy. So I have actually an example from project I've been in. So here at Open Value, we have some kind of little internal application. It's called Talent Finder. And it's actually an application to look how good the skills of an employee map to the project requirements of a customer project. So we can actually then try to find the best match between an employee and the customer project, and actually just apply to the most promising ones to actually save some time and money. And yeah, the search functionality is actually a big part of the application. So at some point we all had like a talent repository, a talent service, a talent controller, and it was getting kind of messy. So what I actually did was I split it up into a talent CRUD repository, talent search repository, and split it all in search and all the CRUD operations. And afterwards, it was getting a lot more, yeah, readable. So that's actually what you should do. Do a refactoring first, and yeah, try to clean up your code a little. But what you might encounter with constructor injection are actually cyclic dependencies. That happens when dependencies try to access each other. And so for example, here's an example. The user service is not created yet, but the user repository needs it. But to create the user repository, we need the to create the user service, we need the user repository. So it gets kept in a cyclic dependency here, and it's not solvable with constructor injection. Yeah, but in my opinion, usually it's assigned to do refactoring as well. So last time I had it, I think it was a few weeks ago. And then, yeah, I just was coding, starting up the application. It was praying, so the error was actually turning up at the runtime. And it said cyclic dependency. And I thought, oh, that's bad. I looked into the methods and thought, oh man, this method doesn't belong here. So it was like, I think it was some search functionality which was in the CRUD operations or something like this. And by just moving it away, I already resolved that one. So usually it's a sign that maybe like the control flow is not really how it should be, and you should start to work on that. But depending on your code, it can get kind of difficult, and you might not be able to invest that much time. And yeah, then you might want to use another injection type instead of constructor injection, because most other injection types can actually resolve that one. Or another option would be to simply use something framework specific. So like Spring has this add lazy annotation you can use, and with this add lazy annotation, first a proxy object is inserted. So for example, somewhere over there, then a proxy object would be inserted. And the object itself, the dependency, would then be created when it would be first exited, so at a later time. Yeah, but that's framework internal, so you don't have to do it yourself. So as I said, we could resolve it with a different injection. One injection actually to do it is setter injection. And down here you actually see an example how to resolve the example from before. We just create the dependency first, which has no other dependencies, inject it, and then use the setter to set the cycle. And yeah, setter injection is actually kind of similar to constructor injection, but we inject the method, not through the constructor. There's a field again where we save the dependency in. Yeah. And yeah, let's have a look at the specifics about it. So it's kind of nice because the dependency is optional, and it might be use case for that if you have optional dependencies. But you should be aware of it, because the dependency might actually be null when you want to use it. So this can lead to runtime errors. And you either have to handle it, or you say, yeah, when it's null, something got really wrong. So then the application is in a bad state anyway. But just be aware that this can happen. It's actually a good thing if mutability is needed, so you can actually change dependencies runtime. You could say something like this. So for the first call, we use this dependency. For the second, something else. Totally doable. And it's actually useful for lazy initialization. So you can also do things like create the dependency only when it's needed. So super nice when you want to keep like startup time short. So the dependency then actually just gets created when it's first called. Yeah, and as we saw, because of the creation of the client and the setting of the dependencies actually separated, we can use it to resolve the cyclic dependencies. So next one is also a method injection, the interface injection. And I kept it a little short. I just showed the interface here. What you do here is you just have an inject method where it's defined. And then you actually just implement it. And yeah, that's how you inject them. And you get kind of like a plugin architecture. So all the classes that want to have that dependency actually have to implement that thing. But it feels a little like overhead, like verbose. So every time you have a dependency, you have to create it. And yeah, it's also like kind of the old way to do it. And most modern frameworks don't support it anymore. So you don't see it anymore in most frameworks. But what you do still see a lot is parameter injection, actually. And it's really nice because no, sorry, parameter injection you don't see a lot. I was the next point at fields injection. But parameter injection is super nice because it's so simple. So because what you have here is when you have a method where you use a dependency, you just inject it with it. And it's really nice because it's stateless. So I don't save it. And I get all the advantages from setter injection, because I can inject a different dependency each time I call it. It's only used when it's actually needed. I can use it to resolve cyclic dependencies. And the best thing is actually it's also mandatory in this place. So kind of nice to use. It is? Yeah, it's not that common in frameworks, right? But when you do it like by hand, it's more common. Okay, I didn't know. Oh yes.
Just say, okay, you want to do something special, like a file upload or something. Then you can ask whatever business for that.
Oh yeah. Oh yeah. Yeah, true, true. Yeah, Spring has it also sometimes. Yeah, yeah, yeah. Well, but it's most often annotation based then. Yeah, 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 yeah. So next one, I was a little bit too early, is field injection, and it's actually the most easy one. So we don't have a constructor in there, we don't have a setter in there, we just access the field right away. And yeah, it's really simple to use. But what actually happens if the field is private? So anyone has an idea what to do then? Exactly, reflection. We just used reflection for it to set it, and we actually use reflection to set the field to private, to set the private field. And what we actually have to do is we have to get the class, have to get the declared field. So it's a method get declared field with the field name, then set it to accessible, and then actually set the value. And this is also what's happening when you do add auto-wired in Spring. And it does look kind of nasty, right? So I think it's kind of also the reason why it's not recommended anymore. And there's also another reason, which we'll come to later. So it's also called property injection. So I don't know someone said he's like doing a lot of C#. I think it's called property injection in C#, right? Yeah. It's really simple, but especially when we have the private version, it's difficult to test. Because if I have a test and I want to set the dependency, I either have to use the reflection myself, and if I rename the field, my test breaks again and stuff like this. So it's not nice. Or I'm actually relying on the framework. And if I use Spring for it, I actually have to start up the whole Spring context, and it makes my test slow. And testing is about getting feedback fast, so it's not that nice, right? Yeah, the advantages are actually similar to setter injection. So they can be optional, changeable at runtime, but might not be initialized. So we get the advantages, but a lot of disadvantages by the test at test time. So that's why probably it's also not recommended anymore. And if you'd actually want to make a decision on what to use in the end, my suggestion is actually to always use constructor injection when you can. When it gets bloated, start refactoring. When you have a cyclic dependency, start refactoring. And otherwise, if you can't, or you're just lazy, or I don't know the reasons, just use setter or parameter injection otherwise. And actually try to avoid field injection. Because, yeah, I just said it has all the advantages from setter injection, but it's worse to test. You often rely on a framework, and it might make the test actually slow. So now we have injected all the dependencies, but actually who creates them and actually puts it all together? Who does the wiring? And there's actually two possibilities. You can either do it yourself with manual dependency injection, or you let someone else do it, and it's not your colleague, it's not ChatGPT, it's something like a framework or something. And there's actually two different paradigms in the frameworks. Sorry. But we'll come to that later. So first, let's get started with manual dependency injection. Manual means we actually create the dependencies by hand and inject them. So here we have like a small, could be C-like application or something like this, where we create actually the dependencies one after another and inject them, then use them, and then do some cleanup because we might want to close something. And yeah, it's a nice way. It's good for small applications, but the bad thing is it suffers a lot. So readability actually suffers a lot when you have more than 20, 30 dependencies. It gets really messy. That's why I would actually just recommend it for small applications. And why I used it before is like CLI applications or serverless functions like AWS Lambdas, which actually tend to keep small. So where you know before, it's not going to get big anyway. And usually the point is like, yeah, maybe a few hundred, few thousand lines of code, not that much more. But yeah, you'll feel the pain at some point. But the thing is, you can always switch to a framework, and usually it's really simple. So imagine switching to Spring. All you have to do is annotate your dependencies and remove all that stuff, and then Spring does all the magic for you, right? So why not start like this and then go to a framework? That's what we're gonna do now. So what I said, like frameworks are often annotation based, and you can actually roughly separate them into compile time and runtime. It's two different philosophies to actually do the wiring, and yeah, I'll explain later. And they often use an IOC container. It's called like an inversion of control container, which manages the dependency. It's actually the thing in the end that creates the dependencies, and you can, yeah, you can use to get access to them. And they often have like also some like laser or eager dependency creation. So like the flexible creation of the dependencies. So you might define an order or something, or yeah, like Spring lazy to just say, yeah, it gets first created when you call it. So let's first have a look at compile time frameworks. And like most of the modern frameworks, like the frameworks that were recently released, do compile time. Actually, it means that the wiring is done during compile time. And what happens there is the dependencies are scanned using annotation processing. And when they're scanned, then a dependency graph is actually built. And this graph is used to establish the ordering on how they have to be built. And then they generate code, and it's code generation, so you usually can look into it. I think like Dagger uses a lot of factories, and yeah, other libraries have different strategies. But the code is just generated and then compiles along all your other code. And that's actually a nice thing, because certain errors are actually found at compile time. So like missing beans, missing dependencies, or cyclic dependencies, or stuff like this. And yeah, as I said, it's when you're doing this, it's nice to get early feedback. And a nice thing also is the framework does mostly what you would do by hand. So it's almost no overhead at runtime. Compile time might be seconds longer or whatever, but who cares, right? Another thing is they're often a little less flexible to the runtime frameworks. So it's not always like this. So you can actually change dependencies at runtime based on profiles, properties, or something like this. But for example, Micronaut supports it, but as soon as you do like native code compilation, it might not work anymore. Which means you might have like a dependency you didn't expect it, because you actually have this profile active, but you have the testing dependency there in the end. But it's always easy to circumvent it, because you can also write the logic yourself, right? Instead of having the bean inject a proxy where you say like, hey, return me that object depending on a certain condition, right? So you could say this property is active, so return this dependency, otherwise return that one. And that's what you might have to do. But yeah, be aware that when you use compile time, this may lead to errors. But actually, it might depend on the framework. Yeah, next to runtime. With runtime dependencies, the wiring is actually done at runtime. So while the application is executed. And what happens there is the class path is scanned for the classes. They're then inspected using reflection. And also, like, once again, they use a dependency graph to establish the ordering. But they don't generate code in the end. They create the object and wire them all together. But the big problem here is certain errors only appear at runtime. So like after you compiled, after you tested, it's a lot later, right? And for example, Spring, I think everybody knows like no bitching bean, circular dependencies or something, which only occur once the context is actually loaded. And that's actually why if you start Spring with a Spring initializer, they actually generate one test in there, and it's just a test that starts up the context. And it makes sense to have that at least one test like this in your application because of that. Yeah, but there's also a pro side, like the reflection makes it super flexible. So changing dependencies just isn't a big deal. So the application is running. Yeah, let's look. Let's just create something else then. It's yeah, easy for the framework. Yeah, but the bad thing is there's reflection going on, and it's going on at start time, and reflection tends to be slow. So it is actually performance overhead. And if you want to have like quick startup times, because you do serverless functions or whatever, you want to scale, this might be a big problem. Yeah, it doesn't work. Yeah, it doesn't work with ahead of time compilation, right? It's like, for example, for Quarkus, you do things like add register for reflection, I think, right? We actually put it, I think, put it on a class path before, or something like that. I don't know how it works internally. Ah, okay.
But if it did not test all the possible execution paths.
Oh yeah. Yeah. So less runtime. Let's have a look at some popular frameworks. I already said like Dagger is a compile time framework, and it's very popular in Android development. Quarkus actually brings its own framework, which is mostly compile time. But if you use field injection, it's runtime. So be aware of that. When you do like native image compilation, it might lead to errors. Yeah, and actually I'm a big fan of Avaji. It's like a small, actually like a small collection of libraries, and it has a really nice and small injection framework which you can use, and it's compile time. You can look into the generated code. It's super nice to use. Yeah, from the runtime frameworks, Spring is probably well known to most of us. I don't know who remembers Juice from Google. Oh yeah, but I think it was like really good 10 years ago or something. So it had its prime there. Jakarta brings its own framework, and Coin is one for Kotlin, which is really nice because it's small and it actually has a kind of small footprint for runtime. So it's also a valid option to use. But in the end, we also have to make a decision again, right? And if you want to decide for a framework, I would always say like use the one. If you already use like a big framework that has a dependency injection framework, use that one that's built in, because they're usually so well integrated in the ecosystem. You don't have to care about anything anymore. For example, like Spring with a repository, well, you just create that interface, annotate it, and you don't have to care a thing about closing, opening it, about the connections. Yeah, it's super integrated. Use that one. If it's a small project where you don't have any dependency injection there yet, and you might want to use it, do it manually. Yeah, and because it's simple to switch to a framework, yeah, why not do it? Even though you know you're going to change it later. Otherwise, you're free to choose. Then I would actually recommend to use a compile time framework. And yeah, my preference is Avachi Inject because it's actually it's super easy to use. You can just pull in the library, and mostly you're done. So let's wrap up. That's actually yeah, sure.
So that's used like a standard add inject.
Yeah, it uses the Jakarta annotations. Yeah. At inject, what is there at factory and stuff like this. Yeah. I would like to show it actually, but the time is short. So let's wrap up already. That's actually the few things you should take home. Dependency injection helps you with the testing. If you don't test, yeah, you might not want to use it. But actually, I would recommend testing. Yeah, and it actually helps you to test in isolation. So your test might not fail if you change one class. Yeah, and you can actually combine dependency injection with the dependency inversion principle to create your own fakes and mocks. Dependency injection uses the main idea behind inversion of control, but it isn't inversion of control. It's not full inversion of control. There's many ways to inject. Use constructor injection, refactor, avoid field injection, and otherwise maybe use setter or parameter injection, whatever you prefer to that. I would use parameter injection when you just use dependency once or twice. Otherwise, it might make sense to save it in a field. And yeah, one big thing is there's no need for a framework, at least until you hit a certain size. But if you have one, use it. And if you got the choice, actually prefer compile time. Yeah, that's it. So my slides are here, but I think we're going to share them in the meetup. So thanks, and please ask questions. And yeah, you can always contact me on my mail if you get questions later.
So anyone has a question?
Wait a second.
I think that another reason not to prefer field injection is there is actually, I think, a JEP for closing down on the reflection of private fields.
Yeah.
And then you have to start a JVM with one of these, please let me do nasty things.
Yeah.
And so that will eventually go away.
Yeah.
Anything else? Okay. Then thank you, Jens.